Okay, here we are. We're gonna do one more of these. And this one, let's see. This one. Okay, so here's our original problem here. Um, let's see if we see that. Okay, there it is. Here's our equation, and we're going to differentiate implicitly to find the second derivative of y with respect to x. So we start off, um, and I hate to show you too much of this at once. It's a little unnerving, but okay, so I start off my first step here. Let's take this one step at a time. Okay, differentiate both sides with respect to x. Okay, that gives me this. We have the product rule here, 2x times y squared, and then plus x squared times the derivative of y squared, which is 2y times dy dx, because of the chain rule, minus a 2 equals a 0. Okay, so now we gather things up on the right side and divide by the 2x squared y next to the y prime here, dy dx. So that gives you that. Now you're ready to, I divide it out of 2, and I'm jumping in to get the next derivative, second derivative. This is where it gets a little bit sticky. We need the quotient rule, so derivative of the numerator is in here. This derivative of 1 is 0, but this term here, you need the product rule on it again. So the derivative of the negative x is negative 1 times the y squared minus, now we need derivative of the y squared, which is 2y, y prime. And then times that x gives you this term, times the denominator. Okay, so derivative of the numerator times the denominator minus, now we got the derivative of the denominator, which is, again, product rule, 2xy plus an x squared dy dx times the numerator. Okay, all right, now can keep simplifying here. Here, I put back in the derivative, the first derivative. I put that in place of dy. Okay, the next step, expanding. Okay, and the next step here, just expanding. And you can do this any way you want. I just happen to do it this way. I kept the quantity at 1 minus x y squared intact. And then on my next step, I decided to combine these terms in the middle, the like terms. And then in my next step, I multiplied everything in the numerator by y and everything in the denominator by y. That cleared out this y up in here. And then as a way of simplifying, I decided to factor these terms here on the end here, these two terms. So I decided I was going to factor these as a way of simplifying. You don't have to, you could expand, but that's the way I did it. And then factored out the 1 minus xy squared from both of those terms. I also factored out a negative from the 3 terms on top. So that negative came out first, and then I was left with positives, and they ended up in here. So again, factoring, then I combine like terms in here, and then I did a little expansion. No? Okay, it's this term here times both of those, expanded, combine a couple of like terms, pull that negative back inside, and there's your final answer. It's a lot of work. The second derivative really really was a struggle. The simplification was a struggle.